In this video, we will show you how to define and use common control groups in SIDRA Intersection 7. Common Control Group, or CCG for short, is a SIDRA intersection software term used for a group of signalized sites controlled by a single signal controller. This is relevant to the modeling of signalized, closely spaced intersections, such as staggered T-intersections, traditional freeway diamond interchanges, alternative intersections and interchanges, such as the diverging diamond interchange, intersections with wide median area controlled by signals, and fully signalized roundabouts. Thus, common control groups will refer to signal-controlled facilities that can be modeled as a network of two or more sites as a single entity. In this demonstration, we will be using a project with a network configured for demonstrating a common control group case. Let's first review the layout picture of this network. Now, let's open the Define CCGs input dialog to create two common control groups and allocate the relevant sites to these groups. This dialog consists of two sets of tables. Initially, the table in the Create Common Control Groups data group will be empty. The first step is to define the common control groups in this section for the selected network. Click the Add CCG button. A new CCG with an ID and a CCG name will be inserted in the table for editing by the user. CCG ID is a label specified by the user. Up to 5 characters are allowed. CCG IDs and CCG names will appear in other dialogs. Up to 10 CCGs can be created in this table, depending on the number of signalized sites used in the network. Let's add another CCG. CCG IDs and names are useful for easy identification, especially when multiple CCGs are defined in a network, as in this example. You can use the Move Up, Move Down, and Delete CCG functions to organize the CCGs in the table. Next step is to allocate sites to these CCGs. Remember that a CCG must have at least 2 directly connected signalized sites. Let's first assign the 2 diamond interchange sites to CCG1. Then, allocate the signalized T intersection and the pedestrian crossing sites to CCG2. If the sites allocated to a CCG are not directly connected to each other, a CCG definition error message will be displayed when OK, Apply, or Process buttons are clicked. Note that a site in a network can be allocated to one CCG only, but the same site in a different network can be allocated to a different CCG. When common control groups are introduced in the Define CCGs dialog and OK, Apply, or Process buttons are clicked, the Common Control Groups dialog will appear below the Define CCGs dialog in the Network Input section of the project pane. It is important to note that the Define CCGs and Common Control Groups dialogs should be completed before the Network Timing dialog. Parameters in the Signal Coordination table of the Network Timing Data tab in the Network Timing dialog will be set up according to CCG definitions. Now let's open the Common Control Groups dialog. This resizable dialog includes a Select CCG tab and a set of CCG phasing and timing tabs, similar to the phasing and timing input dialog for individual sites. The Select CCG tab lists the CCGs defined in the Define CCGs dialog for selection using radio buttons. The CCG selected in this tab will be referred to as the selected CCG. The tab also shows the sites that form the selected CCG for information. The structure of the other tabs in the Common Control Groups dialog is similar to the Phasing and Timing dialog for individual sites under the Site tab. These CCG phasing and timing tabs are used to specify phasing and timing data for the selected CCG. The input method is similar to the phasing and timing data for individual sites. In the Sequence Editor and Advanced tabs of this dialog, all sites and movements in the CCG are displayed together for easy data entry. For timing analysis of CCGs, phasing and timing data given in the Common Control Groups dialog will be used, and the data for the individual sites given in the Phasing and Timing dialog under the Site tab will be ignored. For testing different configurations of sites belonging to common control groups, the network can be cloned, and different common control groups can be set up using the same sites. The network clone function will retain all data, including common control group definitions, in the Define CCGs dialog, and the related phasing and timing specifications in the Common Control Groups dialog. Please refer to the user guide for more detailed information on this new feature introduced in SIDRA Intersection version 7.